This video is on topic 2.2, intermolecular forces and potential energy. Today we're going to take a look at some AP questions on potential energy diagrams and applications of Coulomb's law for ionic bonds. My name is Alice Pudi, and I'm happy to be back with you on AP Daily. In the last lesson, we talked about how to read a potential energy diagram and also how to use Coulomb's law when it comes to ionic bonds. And so now we're going to take a look at some practice questions on that. Lattice energy is the energy required to separate ions in an ionic bond. And so you are given here the equation to separate magnesium hydroxide into magnesium ion and hydroxide ions and the energy required to do that. And the same thing for strontium hydroxide. And the question asks to explain why, in terms of periodic properties, the lattice energy for strontium hydroxide is less than the lattice energy for magnesium hydroxide. So please press stop, answer the question, and then press play when you're ready to continue. The first thing that I'm going to address is the periodic property. So the strontium ion is larger than the magnesium ion, and that's because strontium has more occupied shells. And then because of this distance then, Coulomb's law says that the greater the distance between the ions, then the smaller the attractive force. And because strontium and hydroxide are further apart, it takes less energy to separate them, and ultimately your lattice energy is going to be smaller. Next, you're given a potential energy curve for a carbon-oxygen triple bond. And a student claims that the carbon-oxygen single bond will be less steep and shifted to the right compared to the triple bond. And so this question then asks again to do two things. The first is to state, do you agree or disagree, and to explain why or why not. So please stop the video, answer the question, and then press play when you're ready to continue. You can see here that the red curve is the carbon-oxygen single bond. It is less steep. And then if we look at the lowest part of the curve where that matches on the x-axis, that would represent the bond length. And you can see that the single bond then is longer than the triple bond that we have here. This is the end of the video. Thank you for watching. Please join me for the